As Tom mentioned, my name is Carl Bradley. I'm a plant pathologist here on campus. Do a lot of research on disease management in field crops. Today I'm going to speak about fungicides on corn and soybean. This is a topic that you've probably seen me talk about a little bit before. But what I'm really trying to do here today is to kind of bring together, summarize all the data that my program has collected in the number of years that we've been evaluating fungicides on both corn and soybean. Now, so in the past, you've probably seen me focus a little bit more on fungicides on corn, but I will be trying to equally talk about fungicides on soybean today. I know Emerson talked a little bit about some of his research this morning too, so you can see if what I say sort of lines up with what Emerson was showing as well. And so the main point is that I would like to look at some of the different factors that we were able to evaluate and to try to determine which of those factors led to increased yield with the use of fungicides. And then, of course, profitability is very important. Take a look at how often we would have been profitable spraying fungicides on both corn and soybean. And so I think Gary Schmidt, he follows me, and obviously he's the ag economist on the program today. And so from what you see up here on the slide, this is sort of a plant pathologist viewpoint of what profitability means as far as fungicide goes. But basically it's getting a yield response large enough to pay for the price of the fungicide and the application costs. And of course that can vary depending on the price of the commodity as well as the application costs and cost of fungicide. Now I realize that in the real world, oftentimes when fungicides are applied, they are also being applied with other products. Sometimes maybe a foliar insecticide, maybe sometimes other products may go out with that fungicide. But when I'm looking at the profitability here, I'm only considering the price of the foliar fungicide along with what type of cost it would be to make that application. So we've had some pretty decent years in ag here since about 2007, where the commodity prices went up and continue to climb a little bit. Unfortunately, it sounds like we're on our way down. And so what does this mean as far as being profitable with fungicides? It's going to mean that it's going to be a little bit tougher. We are going to need a larger yield response to pay for the cost of that fungicide as our commodity prices go down. Okay, so time to show a little data here. My research program has been evaluating foliar fungicides on corn sort of uniformly since 2008. Okay, and so what I mean by uniformly is that we have what we call uniform fungicide trials at different locations across the state where we apply the same treatments. The hybrids will differ because they're different locations. But you can see up on the map all the different locations in which we have tested foliar fungicides on corn, and then the different years that we've tested these fungicides at the different locations. So if you look at the number of years along with the number of locations, we come up with 40 different environments here in which my program has evaluated foliar fungicides. Normally when it comes time for questions, I often so far have had several questions about timing the foliar fungicides. So as far as the data I'm going to show you, these fungicides were all applied somewhere around that tassel emergence, silking kind of window right there. So it's not the early applications, not in-furrow applications, not V5, V6 applications that we're looking at, but the later ones between tassel and silking. So I often get asked, how do we make these applications? And there's a couple of ways that we can do this. We do have a tractor-mounted sprayer that we're able to move the boom up high enough to clear the corn, as you can see in the picture there. There are conveniences in doing studies like this. You can see the multiple soda pop heads that are on the back of that sprayer. That allows us to change the treatments as we're going through the field. And of course, you also have the advantage of air conditioning in the middle of July there, which is not too bad either. One of the disadvantages, as you can see, when we do this, we have to have dry rows. And so that doesn't always make the farm superintendent very happy when we go out and mow down some corn that we cannot sell for grain to help the farm out. But as you can see, we spray 4 rows on each side, and so we only evaluate the 2 middle rows that were applied. Okay, so we're taking out the non-competitor, the plants there that aren't competing with any other plants on the other side. So we're only evaluating the 2 middle rows for yield and for disease severity. So that's one way to do it. This would be the other way to do it. This is not as convenient because you have to kind of dress up and get really hot when you're out in the field. But this does allow us to save a little bit of land use when we're doing it. So those are kind of the 2 main ways that we're spraying fungicides. Just as a reminder here, I showed this graph earlier. Where would we be considering as far as what type of yield we would need for a return for 2013, and it would be somewhere in that 5 to 8 bushel an acre yield response is what we would need based on the price of corn in 2013 and the fungicide application cost. So somewhere between 5 and 8 bushels we would need to get back to be profitable with the foliar fungicide last year. So these are my data from all 40 environments. You can see that first bar there is the average yield response in bushels per acre. So that's how much yield response over the untreated check that we got with the foliar fungicides. And from all these 40 environments, we're at 5.2 bushels an acre. Okay? Now I talked about being profitable, and that 5 to 8 bushel an acre yield response is kind of what we needed to be profitable last year. If you focus on that green and then a darker blue line, that would be the frequency of achieving at least a 5 bushel an acre to an 8 bushel an acre yield response. Okay, so as you can see here, that occurred between 43 and 50% of the time. So in the first graph I showed you over all 40 environments. This second set of graphs that you're seeing here, these are over 26 environments, 26 of those 40 environments. And in these 26 environments, there was low disease pressure, okay? Less than 10% of the leaf area affected by disease. And as you can see here with that blue bar, you can see that we're now at 2.4 bushels an acre yield response, so it did go down. And if we're looking at that 5 to 8 bushel an acre yield response needed, we're right at 31%. Okay, so not as good as what we saw with all 40 environments. So conversely, what does that look like under a little higher disease pressure? And in 14 of those environments, we had disease pressure where we had at least 10% of that leaf area affected by diseases in our untreated checks. And in this case, in that higher disease pressure situation, our average yield response was 10.4 bushels an acre, and we would have been profitable with that 5 to 8 bushel an acre yield response somewhere between 64 and 86% of the time. So disease does matter, okay? Now, granted, in our low disease pressure, we did have instances there where we would have had high enough yield response where we would have been able to be profitable with the foliar fungicides. But if you're looking for that consistent effect, being consistently profitable, you really need to target disease. Okay, so it's easy for me to stand up here in January and talk about this, especially whenever we're looking at this disease pressure. This is actually after we sprayed. This is not the disease pressure that was there when we made those applications. This is what occurred about 4 to 6 weeks after those applications in our untreated checks when we went back to evaluate. Okay, so how do we make that decision in late June or early July? Well, you really need to scout. You really need to know a little bit about your hybrid, how susceptible it is, but also scouting to see what kind of disease levels that are out there. 2 of our main foliar fungal diseases that we deal with are gray leaf spot and northern corn leaf blight. This is what gray leaf spot would look like early on, pre-tassel, before it's really starting to blow up. If you're seeing gray leaf spot on the third leaf below the ear or higher, on half the plants that you're looking at prior to tassel, then that may be a good trigger to spray from what we've seen in some of our studies. And of course, if you didn't spray, you let it develop to this type of severity, which would be a little greater than 10% of that leaf area. This is when we're seeing this would yield to yield loss, okay? And then northern corn leaf blight, this is what it would look like early on, sort of elliptical lesions. Prior to tasseling, if you saw this on the third leaf below the ear or higher, on half the plants that you're looking at, prior to tassel, then it might be a good trigger to spray a fungicide so that it wouldn't lead to something like this where you have greater than 10% of that leaf area affected, where we've seen yield loss occurring. Okay, so in addition to looking at disease pressure, we've also had an opportunity to look at the effect of rainfall in all of these trials that we've conducted. And you can see here our overall yield response again in those environments where we were able to get rainfall measurements was 5.2 bushels an acre. And then what I have across the bottom are different levels of rainfall that occurred between June and August. So dry situations over to the left, somewhere between 4 to 8 inches, and then all the way up to over 24 inches of rainfall during that period on the right. And then looking at yield response, this is what it looks like. So we tend to see lower yield responses as we get less rainfall. Our highest yield responses were somewhere between 14 and 17 bushels an acre that occurred between 16 and 24 inches of rainfall that was accumulated between June and August. Okay, so it makes sense. The more rain that we have, the better conditions for some of those foliar fungal pathogens to disperse and to be able to cause infection and then cause disease and for that to continue to spread. So what did disease pressure look like in these situations? That would be the orange bar here. You can see that where we had our highest yield responses was also where we had the highest levels of disease. So again, rainfall is a factor. However, what it really drives is that the foliar pathogens that cause diseases. So where we had more rainfall, we had a higher yield response, but that's also where we had a higher level of disease pressure. So in summary, for corn, we see those larger yield responses from fungicides when we had higher levels of disease, and we would have been profitable more frequently if we would have targeted those applications under risk situations that would have led to more likely higher disease pressure situations. Okay, so that's sort of the story on yield. Of course, fungicides are marketed in different ways, and one of the ways that they may be marketed is helping increase sustainability, or maybe another way to look at that would be to reduce stalk rot. Okay, so we have a better standability, which can lead to better harvest efficiency because we're not harvesting corn that's down on the ground. And so in these 40 environments, most of these, not all 40, but in most situations, we were also able to evaluate stalk rot in our trials. And so we do that by, whenever the plants are at that black layer stage, we go out and we take our big machete knives and we'll split those stalks open and we'll evaluate those on a 0 to 5 scale, where 0 would be something like what you see there on the left. That pith is still intact. It's white. You can see that that plant is probably going to be standing for a long time. Okay, it's not degrading. It still really has a really solid stalk on it. Compared to something all the way to your right, where that would be a 5. You can see that the pith is disintegrating, and it wouldn't really take very much wind to knock that over and cause a problem. So we go out and we've evaluated our trials in this manner. And in fact, we did see that foliar fungicides will decrease stalk rot. Okay? That is true. We did see that. However, we did see an association between stalk rot severity, which is what you see there on the x-axis, with our level of foliar disease, which is what you're seeing there on the y-axis. Okay? And with this, we see that when we have higher levels of leaf diseases, like gray leaf spot or northern quarter leaf blight, we also have higher levels of stalk rot. Okay? So why are we seeing this? We do see that the amount of foliar disease pressure plays a major role with fungicides on stalk rots, but the reason that we see that association and the reason we see that foliar fungicides can help increase standability or decrease stalk rot is that we're allowing those leaves to do their job. Okay? So when a leaf has gray leaf spot lesions on it or northern quarter leaf blight lesions on it, its photosynthesis rate is going to be decreased. It's not going to be able to produce enough carbohydrates from photosynthesis to keep up with the demand of the year. Okay? But that demand is still there. So the corn plant then has to begin pulling carbohydrates from the roots, from the stalks, and moving those into the ear. And what happens then is that it predisposes the roots and the stalk to infection by whatever microbe happens to be present. Oftentimes it's going to be a fusarium or a gibberella or something rather common. Okay? So we don't necessarily see direct effect, direct control of those stalk rot pathogens with foliar fungicides, but rather we're allowing those leaves to do their job because we're protecting those leaves against foliar diseases and allow those leaves to produce enough photosynthase to fill the ear. Okay, what about soybean? We've also done a number of trials on soybean. Since from 2007 to 2011, the Illinois Soybean Association was funding my program for this project where we evaluated foliar fungicides across multiple locations. At each of these locations, we had 4 different varieties. Okay, and all these applications were made at the R3 growth stage. And in this case, we did use the tractor-mounted sprayer, as you see there. And so, to do this, we had to have dry rows again. So we changed our planter so that we would plant a couple of 30-inch rows, which would give us our dry rows. And then to each side of those 30-inch rows, we had 15-inch rows. And so the plot sizes that we were looking at here with foliar fungicides were all 15-inch rows. And then similar to what I had shown you with corn, we have a number of locations in which we evaluated fungicides on soybean from 2007 to 2011. And if you look at the number of years and the different locations in total, we had 32 environments. And then looking at the price of soybean versus the application cost, we would be somewhere between needing 2 to 3 bushels an acre yield response to be profitable with foliar fungicides on soybean. And so we wanted to look at a few things here. Of course, disease pressure, as we had looked at with the corn data. Also rainfall, as we had looked at with the corn data. But we had an opportunity to also evaluate fungicides with and without foliar insecticides. And we also had an opportunity to look at plot sizes in some later trials that we conducted that we'll talk about here in a minute. So first off, just looking at our overall data, what it looked like in all these 32 environments. You can see again with the blue bar, we saw an average yield response across all these environments of 2.1 bushels an acre. And if we needed around 2 bushels an acre yield response to be profitable, that would happen 59% of the time. Looking at, again, different disease pressures, in 23 of those 32 environments, we had moderately low disease pressure, where less than 10% of the leaf area in the upper third of the canopy was affected by diseases. In this case, our yield went down a little bit. It went down to 1.6 bushels an acre, not a whole lot, but a little bit. And our frequency of achieving at least a 2 bushel an acre yield response also went down a little bit to 52%. When we looked at higher disease pressure, where we had at least 10% of the leaf area affected in the upper third of the canopy, you see that our average yield response went up to 3.5 bushels an acre, and we would have been profitable with that, with achieving at least a 2 bushel an acre yield response 78% of the time. So that did increase quite a bit compared to the others. Okay. Now we don't see these drastic changes in our yield responses on soybean as we do on corn. You know, on corn we can go up, you know, have a 12 bushel an acre yield response. On soybean, we tend to kind of see this consistent 2 bushel an acre yield response, and I'll show you some more data here that will show you this. This is looking at rainfall between May and September. Again, we have different categories there where driest environments would be on the left-hand side of the graph, and our the most wet environments would be on the right-hand side. In this case, we're looking at direct comparisons of headline and quadrus with an untreated. Across all of these different environments, our treatment list would change from year to year, but the 3 treatments that we had in common across all of these environments were the untreated, headline, and quadrus. So what you can see here is that really, as long as we had at least a 10-inch accumulation of rainfall from that May to September period, we had a pretty consistent 2 bushel an acre yield response across the board. Now, where that did not play out would be in that very dry environment where we had less than 10 inches of rainfall during that period, and you can see that we had no positive yield response with foliar fungicides in that situation. So, from 2007 to 2011, the Illinois Soybean Association was funding that project. Beginning in 2012, funding situation changed a little bit. There was still funding provided, but a smaller amount, which meant that we needed to change what we were doing a little. So in this case, what you're looking at is the new trial that's still ongoing. We have 2 locations here, Monmouth and Urbana. And in this situation, we were evaluating a fungicide alone, a fungicide plus an insecticide, and then an insecticide alone, all applied at the R3 growth stage. And the other thing that we had a chance to do here is that we were able to look at these treatments in what we call small plots, which would have been 10 feet wide by 20 feet long, as well as large plots, which would have been 20 feet wide by 100 feet long. Okay? And so these were conducted in the same field, or if we did it at one of our research farms, it was basically the same land. There might have been just a grass alleyway between the trials. And so same variety, same planting date, same spraying date in all these cases. So looking at Urbana in both 2012 and 2013, looking at yield response here, if you do not see an asterisk, that means that it was not statistically different. So if you look at 2012, you can see that maybe there were some numerical differences there, but no statistical differences. And then looking at 2013, which is the graph on your right, you can see that the trend was the same in the small plots versus the large plots, but we only saw statistical differences in our large plots where we had where the Warrior by itself was statistically better than the check, and then the Quadrus plus Warrior was also statistically better than the check. And then looking at Monmouth in both 2012 and 2013, again in 2012, similar to what we saw in Urbana, no statistical differences there. In that year, the second year in Monmouth in 2013, our only statistical difference came in our large plots with the fungicide treatment alone. So what does all this mean? As far as disease pressure goes, I would say that it certainly plays a role. It's probably not as large of a role as what we have seen with corn. Okay, again, we kind of saw that 2 bushel an acre yield response. Pretty much, didn't really matter so much about disease pressure except for the frequency of how often we would have been profitable. Some observational data. We did notice that Frogeye leaf spot, when it was present, it did tend to cause more yield loss. The other thing we had an opportunity to evaluate here, if you recall, I said we had 4 varieties at each of those environments. And so we were able to evaluate if there was a fungicide treatment by variety interaction. In most cases, there were not, which meant that all varieties responded similarly to the fungicide treatments. The only times where we did see that interaction was when we had Frogeye leaf spot present, and if we had a variety that was susceptible to Frogeye leaf spot. In that case, we did see a larger yield response in those susceptible varieties. That only occurred a couple of times in southern Illinois, 1 year in Ridgeway and 1 year at Belleville, where we had enough Frogeye leaf spot pressure out there to see those differences. As far as rainfall occurs, again, we saw that consistent 2 bushel an acre yield response, except in the really dry conditions. And as far as our plot size and insecticide trials, I would say at this point in time, we're kind of seeing inconsistent results. We are going to continue that project in 2014. Just to wrap up, I wanted to talk a little bit about fungicide resistance. Many of you probably are aware that in 2010 we began to find isolates of the Frogeye leaf spot pathogen of soybean that were resistant to strobilurin fungicide. So I want to give a quick update of what's going on with that. And of course, in 2010, this was a situation, those red dots are the areas where we found these isolates that were resistant to strobilurin fungicides, a couple in southern Illinois, western Kentucky, and then western Tennessee. And then from 2010 to 2012, we began to look a little bit, our search was a little bit more widespread. We had more cooperation from plant pathologists from states throughout the Midwest as well as the southern states. And you can see that we identified these fungicide-resistant isolates really all over the place. And then looking at 2013, those would be the blue dots here, would be the finds from 2013, and you can see we added some new areas there, and we added a couple new states, Indiana and North Carolina. So for the most part, I would say if you are dealing with Frogeye leaf spot, and I realize that it's probably not the most common foliar disease of soybean in Illinois, but certainly as you go further south, especially if you have susceptible varieties, this can be a problem. If you are making fungicide applications to manage this disease, it is important that you use products that contain active ingredients from different chemistry classes. So we want to use mixtures here. And some of our work down at Dixon Springs in southeastern Illinois, where we have a fungicide-resistant isolate present, we've been doing some work for the past 3 years, and just to look at those yield responses from these different products. Headline, which would be a straight strobilurin product. There on the left, we only saw a 1.3 bushel an acre yield response. But from some of the products from different chemistry classes, as well as mixtures, in which we have a large triazole component, such as quadristop, top guard, or topsin, that's where we were seeing our largest yield response in these situations. 2012 data looks similar, and so does 2013. Now, we do have a lot of disease pressure in these trials. Here's what our untreated control looked like from last year. And just looking at what a strobilurin fungicide looks like, you can see we have no control. So, the other interesting thing here, and from these past 3 years of data, we see when we look at headline or a single strobilurin active ingredient, we don't necessarily see that 2 bushel an acre yield response like we were seeing in my 32 environments from 2007 to 2011. So when there is a pathogen present that's resistant to these fungicides, perhaps we don't see that yield response like we were seeing with in the locations that had sensitive fungi causing problems. With that, Todd, I'll turn it back over to you.